Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Nass. I am with Embedded Computing Design, and this week my guest is Larry Richenstein. He is the founder and CEO of WePower Technologies. How you doing, Larry?
Good, Rich. Nice to see you.
Thank you very much. Same here. Um, you guys were just at CES with this technology that's sort of you have to see it to believe it, and I'm still trying to decide if I believe it or not, but would you please explain what you guys do?
Yes. Oh, come on. You got to believe it by now. Um, yes. Energy harvesting. So we harvest energy from kinetic movement, a push of a button, a slide of a switch, turn of a knob, vibrations. We have a lot of different ways of doing it. But the key here is that we are able to harvest more energy than any other company in the world today with the simple push, pull, turn of a
Do you
switch or a
quantify
knob.
the amount of power that you're talking about?
Yeah, we're talking about millijoules, and we're talking somewhere between 2 to 20 millijoules of energy capable of being harvested. And just to give you a feel, the original company that was in this spot 25 years ago, an Ocean, and they're still in it, they're producing about 1/40th, 1/30th the amount of energy. But more importantly, it's the duration of the energy. So they're in the few microseconds. We're about 250 milliseconds. So we probably provide energy for about 100 times as long as they do. And what you can do with that is put more signals out, more beacons for a more robust wireless signal that's going to be received without any question by the hub that's supposed to receive it, assuming like an IoT type situation.
So I need you to educate me a little bit here. Why are you talking joules and not watts?
That's a great question that my engineers could respond to much better than I can. But the whole thing is it's based on what I've been explained, and I'm honestly not in a position to answer this in the way that someone
Okay.
should if they were technically adept, and I'm not.
Okay. All right.
Um, you know, engineers call me dangerous sometimes because I
Okay.
have these
So
crazy ideas, but
explain how it works in practice.
sure.
What are you actually doing to get the energy?
We are using Faraday's law by moving a magnet through a copper coil, but we do it in patented ways where we prolong the energy output much greater than it would be if you just dropped a
Mhm.
copper, a piece of a magnet through a copper coil. It would
Sort of
go
like a
through these.
motor in reverse.
That's right. We are. Yes, we're an electric motor in reverse.
Hmm.
So what we're doing here is when you push the button, we have a way to make a magnet oscillate within the copper coil, providing way more energy than you would if it didn't oscillate. And we do that we have three different generators. I mean, that's important because they have different applications. And, we're talking to a lot of different companies using them in different ways. Our G300 we demonstrated, for example, at CES, our first external demonstration with an external company was a lighting controller. And what we did is the G300 is a slide switch, always meant for lighting as one of its prime use cases. And we were able to work with Focus SB, a very high-end lighting company out of the UK. They make $200 and $300 light switches. And we were able, working with them, to incorporate the G300 in their design and make it work at CES. So we had a battery-free wireless light switch that was turning on and off a remote light.
So if I understand this right, there's a transceiver at each end, and you're powering enough to activate that transceiver.
That's right.
Interesting.
Right.
Okay.
So, and we're using standard circuits. So, I mean, standard forms of these technologies. So, we showed BLE, standard BLE. We had BLE for Home Assistant. We also showed a Z-Wave product. Will be the very first Z-Wave approved battery-free product when we start shipping first quarter, probably early second quarter. of this year our liquid leak detector, which is our first reference product. And
So who would your customers be? Would it be the transceiver vendor or the light vendor?
the light vendor typically, yes. So we're talking to the major lighting companies. As an example, we're talking with major lock companies, of course, today, based on the other demo which we did at CES, which I think
What is
was
that?
the
Explain how the lock works.
yeah, this was the most compelling demo, I think, at CES. We took one of the biggest problems of batteries, and that's in door locks, where they are in every single hotel and
Hmm.
every cruise ship. And we worked with Southco, a major lock actuator manufacturer and developer, to come up with a way to power their most efficient lock actuator. And what we did is we demonstrated at CES a door lock that you would turn 90 degrees, and that 90-degree turn of the knob provided enough energy so that you could hold up your phone or an RFID tag to verify that you're the right person to open the door. The
Hmm.
electronic lock then unlocked electronically, and you could open the door. We could lock it the same way, turn it a quarter of the way, 90 degrees on the knob, and that turning of 90 degrees provides enough energy, again, to verify that you want to lock the door and that you're the right person who's authorized to do so. And then literally will use that 90-degree turn of the knob for energy to electronically operate the lock and lock it again.
So excuse
Nobody's
my
ever seen that
ignorance.
done.
What what is the lock like today? There's a battery in every one of those.
Yep.
And how does that work? Does somebody go around charging those batteries?
uh, Charging or replacing typically. Yeah,
Hmm.
I mean, every hotel room that you go into today that has an electronic lock, and I would say it's been a while since you've seen a hotel that doesn't have one. Those users are using AA, AAA batteries,
Hmm.
and they will run out. And I have friends who've known that I've been at this for so long will call me up. Larry, you wouldn't believe it. I just got back from the Caribbean, and my wife and I went out to dinner. We went upstairs. I couldn't get in the room. It took 2 hours till they unlocked the door by taking the door apart and putting in new batteries. It happens.
From a bill of materials perspective, is it a wash to implement your technology and to remove the batteries?
Um, well, I would say a battery compartment, which is basically two metal coils, right? And some wiring probably costs less than our generators and circuit. However, and this is a big however, what's the cost to a hotel when they have to, over the next 40 years, change batteries every 2 years or every year? And they are running more like every year. If you take a typical guy working in those hotels and you're saying they're working, let's make it low, let's say they're working on $20 an hour, and you're going to have to change over the next 40 years batteries 30 times. You tell me where the efficiencies are in cost here. We're saving people an enormous amount of money.
Interesting. And are there other alternatives to this? Are there different ways to generate that power that you're generating?
Um, I would have said no 2 weeks ago, but there was some company at CES that takes a laser beam from the ceiling and will direct it towards the door lock and enable that to get enough energy to do that. I think our turning of the knob 90
Yeah.
degrees is more efficient and way more low cost. I can tell you that. I think there was $1,000 door lock, but
Yeah, I would agree with you there.
so
Hmm.
the short answer is no.
So what's next for you guys? Where do you go
Well,
from here?
we're still talking to Southco. They're going to be looking at some way to implement this, maybe in a beta program. We're talking to we had a meeting already with Focus SB this week in the UK, along with one of their format suppliers, Kasambi they work with, to see how we can move forward on that project. So there are projects that are moving forward We've got another lock company we're working on now that's also moving forward with the project, it seems. So we've got probably 3 or 4 projects moving forward, and we also, of course, have the water or our liquid leak detector coming out in the next couple of months. So,
So
we've
will
got a
that be
lot
the
going
first
on.
actual shipping product, the leak detector?
Yes, yes, it
Okay.
will. And that really is kind of our pivot. Again, we're a licensing company, but in this particular situation, because we haven't seen people, and Richard, you've been kicking the tires here. You're not so sure. So, we talk to customers and they need convincing too. So, it's taken a while, but I think now there's there's a real need for this, and people recognize that what we're doing is real. We've got enough people who've sampled, tested these. We've been approved for our outputs. I mean, what I'm saying, there'd be no reason for me to tell you I'm putting out 2 to 20 millijoules if I couldn't do that. Wouldn't be getting me anywhere. I'm self-financing the company, so it's not like we've been raising all this money from other people. So this is it. This is all real, and it's happening, and it's just really starting now.
Very interesting. Thank you very
Finally,
much, Larry. I'm
thank you, Rich.
definitely looking forward to following this story as it goes. Very cool
I'll keep
indeed.
you updated. Once we get another deal, you'll know about it.
Sounds good. That was Larry Richenstein. He is the founder and CEO of WePower, and I am Rich Nass with Embedded Computing Design.